Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 7cc, Lesson 9 on comparing samples. This is the last lesson in our statistics unit in Math 7, and it really is the culmination of pretty much all we've done. So let's get right into it and see if we can understand what the point of the lesson is today. When we try to answer these statistical questions, right, questions that have variation in them, we almost always must use samples of populations, right? You know, as we've seen, comparing results from two samples, though, can make a conclusion about populations, or to make a conclusion about populations can be kind of tricky, all right? When we do make conclusions about two populations based on two samples, it means that we are inferring or saying something about a population based on, right, incomplete data. By default, right, samples are incomplete data compared to populations. So let's see how that plays out in our first exercise. It's down here. Exercise number 1. A middle school took a sample of 25 6th grade students and 25 7th grade students to see if 7th grade students spend more time on their homework than 6th grade students. The results are shown in the double box plot below. All right, so let's just kind of make sure of this. Right, you can imagine a school wanting to understand how much time 7th graders spend on homework versus 6th graders. Right? They're not necessarily going to take all of their 7th graders and do the survey and all of their 6th graders and do the survey. They're going to take a sample, in this case, 25 6th graders, 25 7th graders. Right? They survey them in terms of how much time they did the homework, they spent on homework per night, and we come up with these two bar graphs, all right? Or, sorry, box plots. Now, let's take a look at letter A. How much greater is the median amount of time spent by 7th graders compared to 6th graders? All right, well, hopefully, given a box plot, you're able to figure out what the median of both data sets is, and therefore you can answer the question, how much greater is the median of 7th graders compared to 6th graders? Pause the video now and go ahead and try to answer this question. All right, let me just move this out of the way, scroll it up a little bit. We want to keep these things on here just so that we can see them. So first things first, let's figure out the two medians, right? For 6th grade, right, the median is right here. So for 6th, the median is equal to 53 minutes, right? And for 7th, its median is going to be right here. A little bit trickier to see. The median is equal to 64 minutes. So it looks like, if we just do the subtraction, 64 minutes minus 53 minutes, it's 11 minutes greater. All right. So that would immediately argue that, not surprisingly, 7th graders seem to, on average, you know, using median kind of as average, seems to be spending more time on homework than 6th grade students. Now our question becomes letter B. State the IQR of the time 6th graders and 7th graders spend on homework. Now this is going to take us a little bit more time, right? But we know that the IQR is the 3rd quartile value minus the 1st quartile value. So for each of these two box plots, what I'd like you to do is try to figure out what the IQR is. Pause the video now and see if you can come up with those. All right, let me bring our box plot back on and maybe erase some medians here because they aren't part of this. Okay, so for 6th grade, right, we've got 61 and 46. So for 6th, our IQR is going to be 61 minus 46, which is equal to 15 minutes. And for 7th grade, it looks like we're going to have an IQR of 72 minus 58, or 14 minutes. All right, so in both cases, right, we've got these IQRs, 6th grade, 15 minutes, 7th grade, 14 minutes. It's very important to be able to calculate interquartile ranges. Remember, those are the ranges of the middle 50% of the data. It's important to be able to calculate interquartile ranges quickly if you have a box plot. Okay, let's take a look at letter C. What do your answers to B tell you about the variation of the middle half of both data sets? All right, well, pause the video now and see if you can write something down about letter C. All right, well, I mean, what it tells me immediately is the variation of the middle half of both data sets is roughly the same, right? One of them had a variation of 14 minutes. One of them had a variation of 15 minutes. Sure, they're not identical, but they're very close to the same. All right. Now, letter D. This is important. By how much do the samples overlap? A small amount or a large amount? Okay, for this, we want to go back and take a look at those box plots again. And let me erase all of this. So, visually speaking, how much do these box plots overlap? A lot or a little? Pause the video and give your assessment based on the visual evidence. Okay, I would say that they overlap a large amount, right? I mean, you can really kind of tell the overlap by sort of, taking this and this, right? That's the overlap in between those two blue lines, right? The parts that don't overlap is this little chunk out here and this, a little bit more of a sizable chunk out here, all right? But still, there's a large amount of overlap. Okay, so here comes the important part. Letter E. How does the difference between the two medians compare to their interquartile ranges? What does this tell you in terms of making an inference about the populations? Okay, so let's make sure that we understand. There is no question that in this survey, right, when we did this, we found that 7th graders, the median amount of time they spent on homework was more than the median amount of time that 6th graders spent on homework. But that was just for the two samples. The question is, how confident can we be in making the same inference about the populations? Would we feel comfortable now in saying that we believe that the median amount of time spent by 7th graders overall for the population of 7th graders is larger than the median amount of time spent by the population of 6th graders on their homework? Well, we do that, remember our last lesson on sampling two populations, we do that by comparing the difference to the two medians compared to the interquartile range. So I'd like you to kind of take a look at that, all right, and think about whether or not you can really infer something about the populations based on these two samples. All right, well first, let's kind of review what we found. All right, the difference between the two medians was 11 minutes. All right, so 11 minutes was the difference between the two medians. Yep, just wanted to make sure. And the IQRs were 14 minutes and 15 minutes, right? So the IQRs were more than the difference. All right, so this really takes us back to the last lesson, and hopefully you were with us on that one, where we looked at sampling two populations. Because what this is telling me right now is that the difference between the two medians is actually less than the variation in the data sets, right? The difference is 11 minutes, but the IQRs are 14 and 15 minutes. Now, what that kind of tells me is that even though it could be that the population of 7th graders has a higher median time spent studying than the population of 6th graders, right? It could also just mean that in this particular sample, we found that it was higher, right? It could be overall that either it's not higher, you know, or, right, they're just about the same. So we don't feel comfortable in making an inference about the populations because the variation is too large compared to the difference in the two medians. Let me extend our page a little bit. So let's say this: we cannot still red. We cannot make an inference about the two populations because the variation is too large compared to the difference in the medians. One thing that kind of drives people nuts about statistics is that all of statistics, because we're trying to answer these statistical questions that involve variation, all answers to statistical questions are a little bit squishy. They're a little bit like hedged with uncertainty, with terms that sound a lot like they come from probability. You know, we're somewhat certain, we're very uncertain, right? And the idea here, and this is going to be the idea in the second exercise as well, is that we really can only make conclusions about populations based on samples. We can only make inferences about populations based on samples when the difference between whatever we're looking at, typically those are either medians or means, when those differences are much larger than the variation that exists within the samples or within the populations. So let's take a look at another exercise. Okay, now there are very sophisticated tools, and I mean they get more and more sophisticated the farther you go in studying statistics. There are very sophisticated tools that statisticians use to determine if the results of two samples differ enough to make inferences about the two populations that they're taken from. In this course, we can only do it informally. We really can. We do not have the tools. In fact, you won't really develop those tools until you either take college level statistics or let's say an AP statistics course maybe later on in high school, okay? We can only do it informally, and I wish I could give you really kind of like solid absolute rules, but I just simply can't, not at this level. Let's take a look at exercise number 2. A study was done to answer the question, are cars more fuel efficient than trucks? A sample of 20 cars and a sample of 20 trucks were taken, and the gas mileage of each vehicle, how many miles can be driven per gallon of fuel, was recorded. The results are shown below. For trucks, the mean was 17 miles per gallon with a mean absolute deviation of 4 miles per gallon. For cars, the mean was 29 miles per gallon with a mean absolute deviation of 5 miles per gallon. All right, so simple enough, right? We did these two studies. Here we're going to be looking at means and MADs instead of medians and IQRs. All right, letter A, just like before. How much higher was the mean fuel efficiency for cars than for trucks? All right, why don't you go ahead and answer this question. By the way, it really is kind of important to have some units here, right? So how much higher was the fuel efficiency for cars than for trucks? All was done with subtraction, right? And we're just going to have 29 minus 17, or 12 miles per gallon. All right, so in other words, in this study at least, where we just had a sample of 20 cars and 20 trucks, and of course there's way more than that out on the road, in this in this case, what we found was that the cars had a fuel efficiency that was 12 miles per gallon more than trucks, at least the mean was, okay? We don't know about any individual car, any individual truck, but the mean for the cars was 12 miles per gallon more than the mean for the trucks. All right, let's take a look at letter B. What can you say about the variation in the two data sets? All right, simple enough, right? Why don't you go ahead and try to answer this question? All right, well, I think I can say that the variation was roughly the same, right? 5 miles per gallon of a MAD for the cars, 4 miles per gallon on the MAD for the trucks, roughly the same amount of variation. About the same, because the MAD values were quite close. All right, great. Let's take a look at letter C. Based on your answer to A and the mean absolute deviations, how confident would you be in concluding that the average fuel efficiency for all cars is greater than the fuel efficiency for all trucks, i.e. the populations? Okay, so pause the video now and just like before, tell me how confident you would be to make that inference. All right, now unlike the last time, right? This time, the difference between the two things that we're considering, right? The two means is 12 miles per gallon, which is more than twice this MAD, and it's 3 times that MAD, right? So now the difference between the two means is large compared to the variation within the groups, and that leads me to be very confident, right, that I can make this inference about the populations. Very confident because the difference in the means is far greater than either, MAD value. Okay. So how can you tell whether it's good enough, right? In the first exercise, definitely not good enough, right? Because the difference between those two medians was actually smaller than the variation within the groups as measured by the IQR. In this case, definitely enough because the difference in the two means was far larger than the variation in the two groups as measured by the MAD. So here's a little rule of thumb, right? The informal rule for inferring. If the difference in the medians of the sample is greater than their interquartile ranges, all right? So in other words, if I'm using median and interquartile range, then what I need the difference between those medians to be larger than the interquartile range values, right? Or if the difference in the means is greater than twice their mean absolute deviation. And remember, the mean absolute deviation, right, the MAD, is roughly half the IQR. So we're kind of saying the same thing here, right? We're kind of saying, like, look, in either case, we need the difference between the two things, the medians or the mean, to be greater than blank. And that blank is either the interquartile range or twice the mean absolute deviation. So if that's true, then we can say that one population mean or median is likely greater than the other. Notice I can't say it's definitely greater than the other. I can just say likely greater than the other. And when you get into sophisticated statistics, you start saying things like, I'm confident I have 95% confidence this is true, or I have 99% confidence this is true, or I have 90% confidence this is true. You'll never have a statistician ever say, I am 100% confident that I can go from these samples to this population. And they can't do that because, again, if you were back with us when we sampled when we took samples from two populations, you could get amazingly unlucky and like take a sample from one population and a sample from one population that are just amazingly misleading in terms of what the overall populations are doing. Okay, but this is a good rough rule of thumb. The problem really becomes when you're close. You know, what happens when the difference between the medians is right around their interquartile range, or the difference between the means is right around twice the MAD, but maybe not quite, you know, then it becomes way more fuzzy. Okay, hopefully you'll never be faced with a situation like that at this level. Okay, maybe later on when you do stats, but not at this level. So let's take a look at one more exercise. Nice simple one in exercise number 3. The amount of time that it takes to get to work is called the commute time. Samples of 50 commute times for Los Angeles and New York are shown below. Based on the box plot, can you conclude that the median commute time for all New York City residents is greater than that of Los Angeles? All right. So that's kind of cool, right? We got this box plot for New York, right? We have this box plot for Los Angeles, right? It's very clear that New York's median commute time, which is right here, is larger than that for Los Angeles. The question is, just based on these two samples, right, just 50 commute times. Remember, LA and New York are the largest cities in America. We're talking about millions upon millions of people. Can we take this sample and then infer to the populations that the same thing is true? Pause the video now and tell me what you think. And the answer is definitely no, right? And it's no because, first off, let's just take a look, right? Let me first write down no. It's hard to tell what the exact difference in the medians here is, but we can kind of estimate it. The difference and the medians is about 3 minutes. 3-minute difference in the medians. But the IQR values are much larger, right? And they're very different, right? Right, the IQR value for New York City residents is about 6 minutes, give or take. The IQR value for Los Angeles is about 15 minutes, give or take. By the way, if you live in either New York City or Los Angeles, you probably know why that is, right? Most New York City residents will take the subway or walk or whatever to work, right? Pretty predictable. Los Angeles folks take a lot of cars to work, things like that. Less public transport there, so they can have these like times that vary much greater. But that doesn't really matter. I mean, I think one thing we could say for certain is probably the variation, you know, in the population for Los Angeles is greater than the variation in the population for New York. But in terms of making a conclusion about the median commute time, we cannot, based on these results, infer anything about the populations because the difference in the medians is too small compared to the variation in the data set. All right. Believe it or not, that's where we all come to in this unit, right? This unit, which has been all about statistics and answering statistical questions based on samples that have been taken from populations. And at the end of the day, what we should take out of this lesson is similar to what we took out of the previous one. If we're trying to say something about populations based on samples, the differences in either the medians or the means must be large compared to the variation in the groups themselves. How large? Well, if we're working with medians and IQRs, we want the difference in the two medians to be bigger than the IQR of the groups, assuming that the IQRs are roughly the same. And if we're looking at means and mean absolute deviations, MAD values, then what we want is we want the difference of those means to be at least twice the size of the MAD value. We actually want it to be much, much more. The more the difference in those means are greater than the variation in the data sets, the more confident we can say that the sample results can be inferred or extended to the populations. All right, I want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. Until I see you again, keep thinking. and keep solving problems.